complex number, when I say 2 plus 3i, what do I mean? Can I represent it in a diagram? So 2 plus 3i can be represented in a diagram called Argand Diagram, which is somewhat similar to our graph sheet. So graph sheet we generally call x-axis, y-axis, the Cartesian plane. This is x and this is y. Instead, in an Argand diagram, the x-axis I call real axis and the y-axis I term as imaginary axis. So when I say a number 2 plus 3i, where can I mark it? 2. So mark it in the real axis. 3i. So it will be here. So it is somewhat like our 2, 3. But here 2 is the real part and 3 is the imaginary part. Now let me call this as z. What all I must know about this z? Can I join this 0 and this z? Yes, of course. You can use your scale and join. What is this distance called as? The distance I term modulus of z. The distance I term modulus of z. So the number z equals to 2 plus 3i, I mark as 2, 3, which is called an Argand diagram, and the distance from the origin, which is nothing but 0, 0, is called modulus of z. How will you find out the distance? We all know the distance formula. Root of 2 minus 0 the whole square, that is 2 square. Plus root of 3 minus 0 the whole square, that is 3 square. So what is modulus formula? 2 minus 0 is 2 only and 3 minus 0 is 3 only. So whenever I say modulus, let us remember in short square root of squares. Real part square plus imaginary part square, and I understand modulus means it is distance from the origin for a particular number. Now, there is yet another notation, z bar. What does this mean? When I say z is 2 plus 3i, I can write z bar as 2 minus 3i. See, what have I done? The real part I didn't change, whereas the imaginary part I changed the symbol. So plus 3i means I write minus 3i. So this is called what? Conjugate of z. So I have two important things associated to a complex number. Can I mark it here? Yes, of course. Mark the negative side of it. This is 2. Minus 3 will be somewhere here. So this is z bar. And if I join, what is this distance? Mod z bar is equal to, this is a number 2, minus 3. 2 minus 0 the whole square, 2 square only. Minus 3 minus 0 the whole square, that is also 3 square only. Because minus 3, when I square, it becomes positive. So what do I say? These two are naturally equal. So in a complex number system, the basic things that we have to remember, z I call 2 plus 3i means modulus of z is 2 square plus 3 square and square root of it. Z bar means treat the real as it is, change the symbol for the imaginary alone. Now, what about minus z? What do you mean by minus z? Whatever is coming in z, just change the symbol. So plus 2 means I write minus 2. Plus 3i means I write minus 3i. So this is yet another notation to remember. The negative of z means change the symbol of real part and imaginary part. Are these two equal? Minus z, change both the symbols. Z bar means change the symbol of imaginary alone. Now, how to add, subtract, multiply, divide two complex numbers. So whenever we are learning a number system, I must immediately know how to add two numbers, how to subtract two numbers, and how to multiply two numbers. Let me take, for example, 2 plus 3i, one number, say z1. Another number, say minus 3 plus 5i. How many numbers are given? 2. How should I add it? z1 plus z2 means you can write like this if you are a beginner. I am adding real and real, imaginary and imaginary. So what is my answer? Minus 1 plus 8i. So by addition I mean real and real you add, imaginary and imaginary you add. Now how to write z1 minus z2? z1 is 2 plus 3i. The symbol minus z2 tells me a little earlier we said negative. Change the symbol for both. So minus 3 will become plus 3. Plus 5i will become minus 5i. Simplifying the answer, 2 plus 3 is 5. 3i minus 5i is minus 2i. So we have learnt for addition or subtraction, the real numbers together, the imaginary numbers together. Plus means just add and write. Minus means z2, change the symbol and then add it. How to multiply two complex numbers? Let us multiply. 2 3s are 6. 2 into minus 5i minus 10i. Ordinary arrow mark I am doing. Then 3i into 3, 9i. 3i into minus 5i. Plus into minus, minus. 3 into 5, 15. I into I square. I square value minus 1. So first time I write I square. But when I add and write, instead of this I square, I have to replace what? Minus 1. So 6. Minus 10i plus 9i is minus I. This minus 15, I square value minus 1. Minus into minus plus. So 15 plus 6, 21 minus I. So in exercise problems, where and all product is coming, you can multiply using ordinary arrow mark. And remember, whenever I square is coming, minus 1. Just recall, root of minus 1 only we term I. Squaring on both the sides, I square will become minus 1. Instead, you can remember this pattern also when you are multiplying. So either full multiplication like this, or when I multiply, to write it in another word. Real and real, 2 3s are 6. Minus imaginary and imaginary. Why I put minus symbol? Because I square gives me minus. So real and real, multiply and write. Imaginary and imaginary. But what symbol I am allotting? Minus. 3 into minus 5, already 1 minus. So minus into minus plus, 3 5s are 15. Plus I into real and imaginary, imaginary and real. Real and imaginary. 2 into minus 5, minus 10. 3 into 3, 9. See what is my answer? 21 minus I. So whichever method is comfortable, you go with that. This is ordinary multiplication, what we do in algebra. Wherever I square is coming, put minus 1. In other words, we multiply like this. Real and real minus imaginary and imaginary. When I say imaginary, don't see I. Only the numbers. 3 into minus 5 minus 15 of minus is plus 15. Then plus I into real and imaginary, imaginary and real. So 2 into minus 5, 3 into 3. When I put this type of arrow mark, we don't see I. We see only the numbers. Both are same answer. Whichever method you are comfortable with, you can proceed. Now the question is how to divide two complex numbers. 2 plus 3i by 3 minus 5i. Now in complex numbers, let us remember a very important condition that we do not keep complex in the denominator. Supposing a complex number comes in denominator, multiply the numerator and denominator by the conjugate. Remember the word conjugate? Minus 5i means it will be plus 5i. So 3 minus 5i, the conjugate will be 3 plus 5i. The numerator also I put 3 plus 5i. So I multiply and divide the same number. My answer is unaltered. Now, how to multiply this? Denominator is a plus ib, a minus ib. This is nothing but a square plus b square. Usually in maths, a plus b into a minus b will yield a square minus b square. But in this problem, I have I extra fitting. So this will be I square b square. And what is I square? I square is minus 1. So minus 1 into minus b square means it is plus b square. So let us remember, whenever I multiply a number and its conjugate, my answer is so simple, square plus square. 3 square plus 5 square. Do not see the symbols, all that. Squaring always yields positive quantity. The numerator. Already we learned how to multiply. So we are going to apply that pattern. How to multiply? Real and real minus imaginary and imaginary. 2 3s are 6 minus 3 into 5. What is my answer? 15. Plus I into real and imaginary, imaginary and real. 2 5s are 10. 3 3s are 9. This arrow mark and all you put in pencil. This is for your clarity. You can have it in mind and do the calculation also. Well, what is the answer? 6 minus 15 minus 9 plus 10 plus 9, 19 into I, 19i. Denominator, 5 square is 25, 3 square is 9. 25 plus 9, 34. So 3 square plus 5 square. My answer is 9 plus 25, which is nothing but 34. Put this 34 for each term separately. So by 34. So division is nothing but conjugate multiplication. So denominator, whatever is the number coming, let me multiply numerator and denominator by the conjugate. Conjugate means change the symbol for imaginary. As I multiply, denominator becomes a simple concept, square plus square. So 3 square plus 5 square. The numerator, you can apply any of the product method. So here I have done real and real minus imaginary and imaginary plus I into real and imaginary plus imaginary and real. As I simplify, put the denominator separately so that this is real part and this is imaginary part.